quick introduction and icebreaker, and then we'll get into the talk. So everybody get comfortable. Our talk tonight is DevOps Automate Everything, which I know everybody is super excited for. But first things first, we want to thank our sponsors. How do I go next? Oh, sorry. So this is our agenda. We're going to thank our sponsors. We've got the icebreaker. We'll do a quick recap of who we are, what we've got coming up in the future, and then we'll get into our main talk. So first of all, thanking our sponsors. Embark Collective, obviously they are hosting us here in their space, and I'm going to pass it over to Evan to tell us a little bit about them.
Hi guys, how's it going? Can I ask a question of who here has been to Embark Collective or has been in the space before? Not too many people, cool. So I'll just be quick. I won't take up too much of your time. I just like to spread the word of Embark Collective and all that we do here for our wonderful member companies. Embark Collective is an educational nonprofit that supports tech-enabled startup companies. So unlike an accelerator or an incubator where there's a prescribed curriculum that companies would go through to help accelerate or tweak their pitch or whatever that may look like, our curriculum is based off of the needs of our startup founders. So each member company is matched with an account manager that helps them and sits with them one-on-one. We've got one-on-one coaching and programming that, again, is cultivated around each and every one of our startups' needs in their individual needs. Just like you and I have different needs, each company does as well. So we don't just have one kind of technology. We have a bunch of them, sort of health tech, fintech, you name it, we've got it here. So if you're ever interested or you'd like to learn more, just let us know. My card is at the receptionist's desk, and I'd be happy to answer any questions you may have. Thank you so much.
And our other sponsor is BrookSource. BrookSource is a technical recruiting company, and they wanted us to remind everyone that they are hiring right now. I believe the positions that they specifically are looking for are listed here. They said that they are looking for all levels of experience, and they also provided a contact, the email, sally@brooksource.com. So if you are looking for a new opportunity, be sure to reach out to them. And now we're going to get into our icebreaker. If you haven't used Quicks before, it is pretty easy. You pull out your phone and then you go to the link that I will put on the screen. Ooh, fancy. So it's quicks.org, quicks with a Z.org. The game pin is 506446. Looks like I've got some people joining. We'll give it about a minute for everyone to join, and no pressure. Right here, this t-shirt. Didn't know that you were also modeling. Okay. All right, looks like I've still got some stragglers coming in. I'll give it about 15 more seconds. All right, let's begin. Oh, nope, still got people. Who's got the emoji for the name? I like that. All right, we'll get started. DOM stands for what? Ten more seconds to get in those answers. Document Object Model. Way to go at Orlando. I know, who's at Orlando? Don't be shy. How are objects organized in the HTML DOM? Hierarchy. At Orlando again, nice. Next question. JavaScript is a blank language. Object-oriented, and specifically, it is a prototype-based object-oriented language. Ooh, Justin S. taking the lead. Next question. JSON stands for what? Playing? Oh, you are playing? Oh. Get your answers in. JavaScript object notation. Justin S. Still on top. Next question is, the process of translating an object into a format suitable for transfer over a network or storage is called what? You guys are fast. Most of you have already answered. Serialization. I hear a yes in the background. I like the enthusiasm. Justin S. still on top. Who's going to get that t-shirt? Next question. What serializes only the enumerable own properties of an object? And again, serializes only the enumerable own properties. This is a tough one. JSON stringify. Justin S. Come on, guys. We need some competition. Next question. I believe we have 2 questions left. What is get? Version control system tool. Connor, nice. Next question. Who is the father of the World Wide Web? No Googling. Tim Berners-Lee. Still on top, Connor. Nice. I think this is our final question. What year did Tim Berners-Lee write the first version of HTML? What year did Tim Berners-Lee write the first version of HTML? '93. Adam. I know. I'm like, who's Adam? Was that it? Oh no, I lied. We have more. Oh no, I didn't lie. That was it. Okay, Adam. Who is Adam? Because you won a t-shirt, my friend. Yes, my friend, go talk to Vince. Woohoo! Yeah, Vince over here in the gray. I'll get it for you. Nice.
That's it.
Fun music's over, but you still get the t-shirt.
You got mediums and large. Okay, and now a little bit about us. So we are Tampa Devs, as I'm sure you saw on the meetup invite. And what we're really looking to do is foster a community so that developers like us can get together and we can learn from each other and we can hang out and have fun. We have talks like this. We also have networking events. I do really want to emphasize that we're always looking for speakers, and giving a talk is a great way to make yourself more visible in the community, as well as to deepen your skills and knowledge. Personally, I've given presentations, and there's nothing quite like the pressure of having to talk about something in front of other developers to light a fire under your you-know-what to understand it really, really well. So again, we're looking to build a community, and we're looking to grow that community. If you want to be a part of this community, there are different ways to get involved, and one of those is going to be speaking and giving presentations, and there are other ways as well. You can always reach out to us via our Slack or email if you're interested in helping to organize. We definitely are growing. I think at our last meetup, we had about 60 attendees, and that was in person as well as virtual. And then tonight, I know that we had more than 75 people RSVP. So it's really exciting to see this community get bigger and to see the enthusiasm that people have for speaking and for showing up for events. These pictures here, I believe, are specifically from our last event, right, Vince? Yeah. So you can see that we obviously have a fun time. We've got t-shirts, we've got stickers. The t-shirts are $20. If you do want to purchase one, you can talk to Vince or send him a DM. We also have hats that are coming in the end of May. And yeah, and if anyone doesn't know Vince, make sure to introduce yourself at some point. He is such a great guy. So I just want to give some updates on kind of what's in the pipeline for Tampa Devs. So we're still going for like 1 or 2 events a month. Next week we have a meet and greet over at Armature Works. We actually had one last week as well, or sorry, last month, and everyone loved it. We had both like the professional groups in Tampa show up as well as like our own group, and we had like 100+ people. It was ridiculous. And actually a lot of members actually asked like rehost that this month as well. So I ended up just creating this one for next week. We're gonna have at least 60+ people from like both our side as well as like the other Tampa 20s and 30s groups. So if you've never been to Armature Works or you just want to have a good time and just meet new people from like different industries, definitely check it out. So this is like a really big update. So TADHack Global is a hackathon, right? And they are like all over the world. And it's simply for telecommunications. So think of like SMS notifications or text or whatever. And a couple of us have actually competed there before. Jonah
where's Jonah? Jonah and I have competed there. Doug and I have competed there as well. And I'll introduce Doug as well in a bit. He's a speaker for today. And we actually got sign off from the organizer to actually host TAD Hacks here in Tampa. And the biggest thing to know about this prize or about TAD Hacks is there's a lot of money involved. Like everyone who competes in TAD Hacks usually comes back a little richer. So yeah, Jonah would know. Jonah would know. Yeah. Our two teams combined won like $5,000. So it's kind of ridiculous. But we definitely have this in the pipeline. I've been talking to different sponsors about hosting it, as well as sponsors that are going to help fund it as well. And we got the logistics sign off from the organizers themselves. So look forward to that. That's going to be in October. Yeah, and then we have a meetup page for that as well for any updates. So definitely check it out or keep it on your radar. I know there was a USF hackathon recently. We got Hung and Nicholas, who both won 3rd place over there. Say shout out to them. Yeah, so, and you guys, like, hackathons are great. Like, you've learned so much in the last weekend. Like, just having to grind, like, figure out how to, like, deploy something to the web for the first time and figure out how to, like, Stack Overflow something at the last minute at midnight. And it's like, we need to get this shipped out tomorrow. And then you get it shipped out and you're like, man, I'm so proud of, like, what I accomplished. And then you might even get a job from it too. You never know. So, yeah. And let me go to the next slide. So we've got, you know, all of our social links. We're at Tampa Devs on Twitter, LinkedIn, Instagram, and Meetup. And you can use hashtag Tampa Devs as well. There's a bit.ly link as well if you want to join Slack directly. Slack is like an internal chat community that we just like message each other about, like, hey, what's your current like workstation look like, or what's interesting around town, right? It's just like a casual place to like just talk to people. TampaDevs.com has all of our information. And then if anyone's interested in speaking, like Lydia was saying earlier, we're always looking for speakers, and it's a great way to get your name out there. Like, instead of just saying you're a developer, you're now a speaker and a developer, and that makes things so much better when it comes to looking for another job. And also, if you come up here and speak, I'll like make you look really good in like photos. So, yeah, without further ado, I want to introduce Doug. So actually, me and Doug have a long history. We've actually competed in a bunch of hackathons together. I think that this was back in 2019, I think.
Yeah.
Yeah. So
we did the game jam first.
Yeah,
That's where we first met.
We did a gaming jam hackathon, and you didn't even know how to code it then. You were still in school.
No, yeah, it was that was like, yeah, I was still in school before that.
Yeah.
Time, so.
And then that was like the first hackathon we had together. And then
asteroid game.
We built like this thing called Asteroid Battlegrounds. It's just like a bunch of asteroids flying in the air, and you're just trying to like survive as long as possible. We tried to make it multiplayer, but it didn't work. Anyways, we competed in TAD Hacks as well, the hackathon I was telling you about, and then we won like $5,000.
Yeah.
Yeah, and then since then, like now he works at our company too. Like I work for Medicare, but we actually work at like a government agency. But it's been awesome seeing your journey, just where you come so far. But anyways, I'll hand it off to you.
Thanks. So just to continue a tiny bit with what Vincent was saying about TAD Hack. If you haven't before, I would definitely recommend attending. Doesn't even necessarily have to be TAD Hack, or could be just they have local game jams or something. You just make a game of the weekend. Super fun. If you haven't worked in like any kind of team environment before, then it's the best way to get that started, because yeah, it's just really casual. It's very fun to just have a kind of feel the energy of like something gets fixed, some issue comes up, you all just work on it together in the like a shared environment like that. Okay, so going to be giving talk on DevOps. So just a little bit about myself. Been in DevOps not super long. It's about 2 years now. So I started with a company called Illusion. That was an internship. If you look at the bottom of any school websites. A lot of times you'll see Illusion at the bottom as like a trademark thing. They do a lot of stuff for Blackboard or Canvas. And from that, I had a lot of things I learned there because they just had a very open setup for their interns. We basically could just go around, meet all the teams, and get to break stuff, and we didn't have to get fired for it or anything like that. And after that, I worked for a more, it was like under 50 employees. It was a local business, and I did a lot of AWS work for them, worked a lot with CloudFormation, and yeah, I hope I don't have to work with that too much anymore. It's a little bit annoying to work with. We'll talk about some alternative tools today that I like a lot better, but that one was fantastic learning experience for me. Basically, had to just put out work, senior dev level work, like every day, even though I was like very new, had some imposter syndrome type stuff going on. But yeah, you just get thrown into it and you kind of just learn, and you are able to connect with people, and usually just everyone that you meet in these kind of workplaces are helpful about it, and they'll, let you know about what to do. So that brings me to where I'm at now, Oddball, which actually knew about them from what Vincent was, who I met at the Game Jam, and yeah, love it so far. Work with really great tools and stuff. So that's a little bit about my experience. So let's talk about DevOps and what it is. So this is kind of the 4 things I would pin down as what DevOps is. The big thing is automation. You want to get your product that your front end or full stack team is giving to you, and you want to be able to get it out there and host it, and you want to do it in a way that's very secure, and you do that through a lot of testing and scripting. So it kind of covers everything that's in those little bubbles there. So there's a little bit of struggle in finding exact stats for this because Bureau of Labor, for some reason, hasn't really go into details yet for software field. They basically just lump everything into software field, even DevOps. So, but the whole of software field in the US is projected to grow 22% over the next 10 years. That's starting 2020 to 2030. So that's huge growth when you compare that to what the median is supposed to be, 8%. So it's about triple any other sector out there. And I was able to find a Stack Overflow survey that put DevOps at 12%. That was like a self-reported about 10,000 respondents. So yeah, I would go with that. About 12% of the software field is DevOps. So that ends up being about 50K jobs that are going to be created in the next 8 years or so. So that is huge. And there's not really, that's huge demand, and there's not enough DevOps people out there. So that ends up being ridiculous salary numbers that are very acquirable if you're able to get these skills mastered. So yeah, it's great job. So this is a website that you can go to intimidate yourself. They have they have all sorts of different career paths. They've got, your front end or DevOps. So yeah, it has a lot of things on here. Yeah, this is the gauntlet. So first thing it's going to recommend for people going down DevOps is to learn a programming language. So it does pin personal recommendation from the roadmap community is to learn Go. And that's because Docker and Terraform are both written in Go. I actually got to first learn Go a month ago. And I would agree with what the box says under that. It doesn't really matter what programming language you learn, just that you learn one. just get started on something. If you're completely new to programming, go with Python. And I'm not going to go super into detail with this just because we're actually going to get a lot of hands-on for this talk. So yeah, we can skip over some of these boxes. Just keep in mind roadmap.sh is a great way to figure out like, what do I need to know to get into this career field? It's not even entirely need to know every single box in here, but good to know like what some of these concepts to understand before you start applying for stuff. So there is like a billion different Linux distros out there. CentOS that's end of life at this point. But yeah, the big ones I would recommend are Fedora or Ubuntu. Those are kind of the most relevant as of today. I would stay away from Windows servers. And yeah, we're gonna get into Bash, which is all this kind of area here. So yeah, you want to be able to be comfortable in the terminal if you're doing DevOps. You're gonna do a lot of stuff in command line. And there is network stuff to learn because the old way of doing infrastructure and getting stuff hosted was to be sysadmin, have lots of local servers. But you know, today, a lot of people don't want to make that initial investment, or they don't really have the capabilities to. So yeah, you got to learn some of these cloud providers and know some of these are, you know, network security and protocols. I'm looking at that one. That's obviously like something that still applied 20 years ago and still applies today. But yeah, understanding how to set up reverse proxy, load balancer, firewalls. Nginx is actually what we're going to use for a little bit of a demo later. That is kind of the go-to Linux web server. And coming down a bit, it's good to understand a lot of these tools you can kind of get hired off of some of just knowing some of these learned infrastructure as code tools here. There's just a ton of companies that are wanting to understand Kubernetes and apply it. It is complicated and it is a little bit advanced. I haven't had a job yet where they've really fully implemented it. But we are going to be working with some Terraform. Told you before, I worked with some CloudFormation before, but that's setting up your cloud infrastructure as code. And Ansible is kind of configuring that infrastructure once you already have it out there. And Docker is kind of the go-to way of doing containers. It's really just like a kind of the next generation of virtual machines, really. And part of that automation that I talked about is getting your stuff out through CI/CD. I like to call it pipeline. There's a lot out there. There's actually so many options out there today. GitLab is probably the most sophisticated one out there, but a ton of companies are using Jenkins just because it's free. But yeah, we'll talk a little bit about that later. We're actually going to be using a demo of GitHub Actions, so that'll be fun. And if you run into issues when you get something hosted, you're going to want to be able to log it and understand what went wrong. So that comes with the use of these different services here. Again, these are, you can kind of just look at the purple check marks as the ones that are like popular. It's not like one company's running every single one of these. That's kind of absurd. And yeah, lastly, there are cloud providers out there. Hopefully you've heard of AWS. They serve about half the internet. And yeah, anyone is good to learn. AWS is an absolute beast. It is complicated, lots of services on it. So that one's hard, but there's a ton of demand for it. So if you feel like you're up to it, I would definitely try and learn stuff on AWS. And that's enough of the roadmap. Oh, just another tab. So we're gonna keep some focus on just some tools in here. These are some of the most important things to learn in DevOps. We're gonna be learning some Terraform first, going through some Bash and Linux, and we're gonna learn a tiny bit about AWS, but there's just a lot out there, so can't really cover too much. And then we're gonna do some GitHub Actions and Docker. Okay, so getting into kind of a 101 of Terraform. On the right, you can see an example Terraform file, what it might look like. And again, this is infrastructure as code. So each one of these blocks here where it says resource, that's going to be creating something in the cloud. And yeah, you just write it out as code, and after you run it, you have those cloud resources. It is declarative in its nature. That is important because you really just tell it what you want and it'll go out there and just do it. So you don't have to have a real fine understanding of what is already out there. It'll kind of just figure those things out. It's very smart. For example, if you have like 4 servers and you want to add 2 more, or really you just tell it, I want 6, and it's going to figure out I need to add 2 more. And one thing that's great about it is it's not locked into anything. Here in this example, I'm using AWS as a provider, but you can use whatever you want. They are a really cool tool for that. So just to break down the syntax a tiny bit, you have the provider as the first part of this string here. And then underscores, everything's lowercase, and underscore for writing your Terraform. And then you have the name of the resource, and then a name that's going to be used only within the Terraform file. This doesn't get applied to the resource. And then you have the different key value pairs for the resource. And if you haven't seen this sort of format before, this is close to YAML. And these are just some common Terraform commands you'll run into when you first get into a Terraform folder. You're going to run init. That's going to go ahead and download your providers and plugins. So if we were in that last, looking at that last file, and we ran Terraform init, that would download the AWS plugin, which is like the AWS SDK, which allows Terraform to interact with your account. And it's going to create the .terraform folder, where it'll have like a state file, and it'll keep reference to what exists out there. And if you wanted to update that, you run Terraform refresh. If you wanted to actually get that resources out there, you run your plan. That'll be like a dry run, doesn't actually do anything, but it gives you output as to what you might get. And then you can apply that, and then you can take it down with distro. So we're going to cover a tiny bit of Bash. So this is what a Linux terminal might look like. This is the breakdown of it. You have your user at the host name, which is like the name of the machine, and then the directory that you're in currently, and then you write out your commands, any arguments that it takes, and then these are called flags when they have the dash. Sometimes will be double dash. And then those can even have their own arguments. And then these are just kind of some common Linux commands you'll run into. There's just a ton out there, but if you haven't seen Linux before, you're going to want to know these because you'll run into them all the time. Yeah, we'll do a little bit of these for the demo. For application managers, that was for the Red Hat. I think it's more specifically towards the CentOS or Fedora, and then apt is for Ubuntu. But yeah, these all just help you manage your files on the Linux machine and do all sorts of printing and input and output redirecting. So one thing that you'll run into if you have never learned Linux before is it'll tell you no a lot. You try to do anything, it'll just say you don't have permissions, you can't do that. So this is a little bit of breakdown. I know it's kind of a lot on here, but if you were to run ls, which is list, and then the -l command, that's going to give you all the files in your current directory, and then a breakdown of what kind of permissions those files have. So let's break it down a tiny bit. Yeah, if you're not able to, if you are new to Linux and this is just like kind of a lot, don't worry about it. It's hard to get it the first time. So the name of the files on the far right here, and then we have the owner and the group. So for this, just this first top line, we have a 404 HTML file. It's going to be an owner of root and a group of root. And we are going to have 3 columns of 3 characters: read, write, execute. And it's going to go owner, group, others. So if we just go through, ignoring that very first column, we have read and write for the owner, and then read for the group of root, and then read for all other users. Again, if that doesn't make sense yet, it might take a few tries of trying to modify files and then Linux telling you you can't do that. So one part of getting past that is to change the permissions and change the owner and group. And that's some example commands in the very bottom left. You have change mod, which is going to change the permissions. It's going to change it to 400. What does 400 mean? Well, there's this table I always have to look up. Each number is going to refer to a permission. So we have 4 is read. It's going to give the owner read. 0 is no permission. That's going to give the group no permission, and all others no permission. So if you really want to lock down who has access to a file, you can give it something like 400. That means only the owner of the file can read it. And if you want to change who owns it and also the group, you can use CHOWN, chown, and we're assigning it to owner of root, group of root for that file. And last Linux thing here before we move on, everything is considered a file for Linux. Helps you understand what things come from. If something isn't working the way you want it to, usually it comes down to a configuration you can find within a file in the system. So, and it also applies that philosophy even to input and output. You can redirect. So the kind of main things here to understand are that you can join commands or redirect the output commands over to another command. So you can look at some of these examples here. The first one, this one's splitting it. The standard output is going to go to an output file, and then any error messages that come from this script are going to go to an error text. And then we can also join commands with this pipe. So we're going to cat, which is read the file of the password file, and then we're going to search over that for the 1000. So I can actually test it out. So we would normally get this kind of output if we've read this etc.password. Don't worry, it's not actually showing the password. It just shows an X because it's encrypted, but we have here the line that we're searching for, and it's going to print 1000 is usually the owner of the machine and the standard user. So it's going to have a line there. If we wanted to just get that line, we can do the pipe, joins the commands, and then grep, which is going to search over the text of that whole file, and it's going to find the one that has 1000, which is right there. So there's a short little demo of that. And we have a little complicated one here. This is just kind of nonsense, but you can say echo to print something, redirect that into a new file. I'm just following along with this very bottom left example, into new file.txt. We're going to use the double and, which means we're going to run another command, and it's only going to do that if the previous command did not error. The semicolon doesn't care if the last command error. And we're going to do backslash, which means a new line. We're going to read that new file that we just put the hi string into. Then we're going to, regardless of if that errored, list the files. And then we're going to redirect all output into dev/null, which is trash. So we're basically just saying hi into a file, reading the file, and then listing the files and then throwing that, whatever that says, into the trash. So that's a little bit of Linux. If a lot of that didn't make sense, that's totally fine. It takes a while to understand it. One thing I can recommend is trying to self-host something. If you have an old PC, just wipe it and put Ubuntu on it and just try to get some self-host service out there. There's tons of them. You can find them on GitHub. Like a Plex server or something like that. Some like leadership thing. Follow through some instructions and see how far you can get with it. You'll learn a lot of Linux. So AWS, this is kind of the most popular platform out there for cloud services. And like I said before, it is intimidating. There's just an amount of services on there. Lots of stuff to learn. And because of that, I work for one company that basically works kind of like, you know, the platform Roku. They kind of work like a wrapper around AWS and their SDK, and they basically made a simplified version of it where companies could provision virtual machines. So that's kind of like what a lot of companies do with AWS, and also that's kind of their main selling point as DevOps. Even is just DevOps is, or AWS is complicated, and getting some understanding of that is really what provides value to whoever might be buying all the services that are on AWS, which there's a ton. So really can't cover a huge amount of AWS. There's so much. If you are interested in it, I do recommend like Udemy courses, or there's just free stuff on YouTube as well. Just explain the networking side of it. So most common ones you run into is there's a VPC. If you create an AWS account, you're going to get a default one. Same for these security groups. Subnets, yeah, you'll get subnets. But yeah, some of this will already have a default setup, but we're going to be using a little bit of this for a demo later. The basics of it is that this VPC is kind of like a virtual network that is going to cover a whole region. So the one that you'll commonly see over here is US East 1. And then within that, you'll have availability zones. Those are kind of just like buildings of servers, and they usually are isolated from each other. That is kind of a big selling point of AWS, is that they have lots of redundancy. So if some kind of catastrophe happened and wiped out a availability zone, you've got another one that you can rely on and still have your service functioning. And nothing is able to reach out into the internet without one of these, internet gateway. And then usually we'll have some kind of route table which will direct the traffic. And these are subnets, and this is going to connect to the traffic that's coming from your route table, and you can set these up into private or public. Very common setup is going to be to have your database set up on a private one, and then your front end set up, or server really, set up on the public one, so that way no internet from this outside is going to be able to reach, if this one was the private, be able to reach a private one. And then this little SG lock that's to represent security groups. It's basically like a firewall out right outside of your EC2, which is Amazon's virtual machine. So there's a little bit to understand about IPs. There's not enough of them out there. So one solution out there is to break things up into CIDRs and subnets. This can be a little hard to understand at first because CIDRs look a lot like IPs, but they've got this suffix here, this first column. And that actually makes a whole lot of difference as to what it actually means. So it's your typical IP is going to look like this middle column. You're going to have 4 sets of these 8 bits, which, yeah, they're just 3 digits, but really it's 32 bits of data. And the suffix for a CIDR, which is used a lot of pipelines or any kind of networking stuff to manage it. It's kind of like an IP range is the best way to think of what CIDR is. I don't know. Yeah, I don't think our tech demo will actually use too much with CIDRs, but you'll run into them all the time if you're doing DevOps, because otherwise you'd have a giant list of IPs that's like 1 million long, like literally 1 million long. So this is a great way of setting up a range of IP. So to kind of go through this table that we have here, you could have an IP like this where you have 255.255.255.255, and then we'll have this suffix, and it's going to, I'm going to call it reserved, but really it just kind of cements that part of what's a regular IP, and it makes it it limits how much of that IP is fluid. So it's probably better if I just show this example here. There is a site I found that is a nice visual for it. Let's make it a tiny bit simpler. So you're basically, the suffix at the very end is defining how much of the bits are going to be reserved. So the rest you can assume are open. So if we have 32, there's 32 bits in an IP. So we're reserving 32. There's only one usable IP. If we change that to 31, you can see this count goes to 2. And if we go to 24, we've opened up 8 bits of the IP. We can see the first usable IP is now 1, 10.0.0.1, 10.0.0.254, and that gives us 256 IPs. So we can bring that down another 8, and we have another 8 bits opened up. That brought us up to 65K IPs are within that range, and you can see there's the first to last. And basically, you would set up your network with those reserved amount of IPs, because if every machine had an IP, then yeah, we would very quickly run out of them. So this is just kind of a way that you'll run into to, you know, like if at your house, each device that's connected to your router might have a kind of internal private IP, but you're only going to have one public IP from your router that your ISP is going to give you. That's just because of, yeah, just the nature of it being limited. So those are some limitations for IP and how we interact with them. And that is getting solved with IP6, but yeah, most people are just using IP4 right now, which uses this. Oops. Another thing you'll run into is ports. So the very common ones are HTTP and HTTPS. That's that locked symbol you'll see on the very top of the browser. That means your traffic is encrypted, and the HTTP is unencrypted. For DevOps, a lot of times you'll run into some of these other ones like SSH. If you wanted to open up a shell on a server or remote into it, some of these things are configurable, so you could set your SSH server to something other than 22. But yeah, I would not recommend it. That's essentially like a thing you'll run into sometimes with DevOps for security. You want things to be secure in legitimately secure ways. We call it security by obscurity. And yeah, you want to avoid that. It's not legitimate security. You can't rely on it. It's really just going to annoy hackers more than stop them. So you want to actually stop them. And then these are some common ones you'll run into. Just might have seen these before if you do development. So 3000 or 8080, usually for web servers. Yeah. Okay. So covering some pipelines that you'll run into if you're doing DevOps. I've worked with the first three on here. And yeah, a lot of companies are using Jenkins because it is free. There is something called CloudBees that I've learned, which is like a paid version of it. But yeah, a lot of people running just Jenkins. It's a bit old by now, so it doesn't feel as great if you're near like starting a company or something. I don't know if I would totally recommend it. I would probably go with like GitLab or GitHub Actions for that, and just kind of pay for it because yeah, you'll run into issues, I guess, at some point. It's good to just get the kind of full package for it. So for our demo that we're going to do later, I'm going to, is there a way to hide this? Whatever. That looks like it. Oh, thanks. Okay, so a lot of pipelines are written in YAML. Here's an example of what some YAML is going to look like. Unless you're CloudFormation, then for some reason you like JSON. So what this is going to do is it's going to spin up a server and it'll run the code that you define in here. And usually it's going to automate some part of your process for getting stuff hosted. So in here, it's going to, we'll get a little bit more into it, but it's going to check out your repo using, anytime it uses this uses, it's using something from GitHub Actions Marketplace. So it's going to check out your repo, choose your code, and then set up a AWS CLI and configure it with the credentials you're going to provide it, set up Terraform, and then here's where I am running. This is the only real 2 lines are the only real thing that I'm providing this whole pipeline here. I'm running Terraform in it and applying it, which is going to create all the infrastructure. So this is really nice because if you have this built out, your app team doesn't really need to even coordinate with you. They can really just commit something to Git, push it out there, and then this pipeline is going to pick it up. For this one specifically, it's going to run this anytime there's a push on dev or prod. And then, yeah, you have automated builds, which is fantastic. Yeah, it's what every company should be striving for, what you should be striving for in any kind of thing you're building for as a developer or with developers. You can do other more complicated stuff like conditionals, these secrets with the $ curly bracket. That's something that I'm providing to GitHub, and then it's injecting that into there. And they do have a marketplace. Okay, let's do a little bit of a demo. Can you guys hear me okay without the mic? Is this okay? Because yeah, I would not want to hold it while I do this. Talk a little bit louder. Okay, so I put these are public repos that I'm in right now. If you go to GitHub, Codable, I have Tampa Dev is my first demo I'm going to go through. I have Tampa Type, one of those two. Should be the most recent thing that I pushed to. You can clone it and check it out. I can add a little bit more to the README to explain what it is and what a little bit more about DevOps or anything people might want. Yeah, so we have we can say, here's our repo, we've cloned it. We're, as a DevOps engineer, we need to get this out there. So what do? You can create a Terraform folder. So this is, you might notice from these package JSON package lock that this is a Node application, React application actually. And we need to get it deployed. So we create a Terraform folder. Going to one sec. Yeah, let me open up my editor, this directory. We use VS Code, kind of ubiquitous at this point. So we're going to check out our Terraform folder I've made. And when you run Terraform, it is going to run everything that's in that directory. So it's as if all these get merged into their own file. These are all .tf for Terraform files. So let's go. Yeah. Let me actually do that and that. Does that look okay? Okay. So it isn't too terribly long. I'm just going to try and cover most of what's in this file here. So you set up the provider. This is going to be AWS. You can provide it your access ID and secret, but this one it's omitted. Terraform will actually look into my AWS folder that I have. If you go through and set up the AWS CLI, you'll see how that gets set up. So Terraform is actually going to read it from there. So I don't actually have to define it in this file. I am going to tell it the region though. And this one isn't totally necessary, but it is good practice to do these things. This one's going to keep the Terraform state. Since Terraform needs to have some idea of what exists out there on the cloud, it's going to keep the state. I think I can show you the file later. It's basically just a giant JSON of what exists on the cloud. So in that one example I said earlier, where you have 4 servers and you want 6, it's going to keep a record. Okay, we've got 4 of these servers. So this normally would be stored locally, but what this code block is doing is it's going to store that in S3, which is just Amazon's kind of like, what would you call that? Like a folder. It's like a file system that you can upload to. And we're going to call it codable-tf state. Yeah. And then that's the directory of the file that it's going to go to. And yeah, that's what the actual file is going to be. And this is another good practice here. We're going to pin the version. Terraform is pretty new and it is past 1.0, so it's not as many, but there were lots of breaking changes that came in through minor patches. So it is good to, not patches, minor versions. Patches is going to be the very last digit on the version. It goes major, minor, and then patches. So what this symbol there is, it's going to pin. So you can upgrade this patch, but you can't upgrade these majors and minors. If you tried to run this with this minor version, this file wouldn't let you. So that's just for increased reliability. That's kind of the main goal, is you want to be able to consistently get things out there and not have them break unexpectedly. So doing practices like this is good. This one's good for team environments. This one's just all around just a good idea. So we have our first resource that we're creating with Terraform. This one is a key pair. That might not make a whole sense right now, but it is going to be used in our instance down here. It's basically a public key. So if you've ever done SSH, it's going to be the public key that allows us to use our private key that we're going to have on our machine here to SSH and be authenticated with them. And we're going to give it, here's a key and then value. So key name, we provided this string. And then Terraform provides a file function. And this is, it's going to read that from our current directory. So oops. We're running it from this folder. So this is where it's going to search for it first. And we'll see, we've got right there, key.pub, which is our public key. So it's going to read that. It's basically doing this, if that makes more sense to people. And we have a instance that we're making. And we're going to call it Amazon Linux 2, AL2. And any instance needs to, one required field is to have an AMI. That's basically an image that it's going to build the instance off of. And then this is var. So this means variable, and it's going to read from the variable file. So we have that same keyword for same name that we provided, that variable over there, and we give it a default value. So we can run the Terraform and replace this, and a lot of pipelines do end up replacing their variables, but this means even if you don't provide it, it's going to know to use this instead. And we have the instance type. We're going to keep it nice and free with tier 2 micro, key name. So this is Terraform's way of referencing other resources. We're going to have this first string that matches there, and then it narrows it down by the name that you provided here. And then since it's asking for the key name, we provide the key name. Other times you might want the ID, like on this next line even. So you can set up the thing that you want to reference within that resource. So we also are setting up the security group for this instance, which is basically like that firewall, that lock SG I had on that one slide. It's going to set up with the security group, which we have right down here. We'll get into in a second. And then lastly, it's going to set it with the name of AL2. And one thing, actually kind of newer learning about this, because usually companies don't use the default, but when I was setting up this demo, I realized you can use the default infrastructure. You basically just say we have a special resource here that you can reference. So this isn't actually going to create anything. It's just going to be so I can reference it in other spots, like right down here. And it's a little bit weird because it's going to say it's going to create a VPC, but it's not actually. I don't know why Terraform gives that output, but whatever. And I think this is the last resource. We have a security group, which is, you can think of it like a firewall, and we're going to allow SSH and HTTP traffic. Normally you'd want it a little bit more secure than how we're setting up this CIDR, but just for this demo, it's going to be okay. So here we connect it to our default VPC, and we are going to set up what ports and what IPs are going to be allowed into our instance. So we have ingress is going to be traffic that can come in. So we have a matching from and to port, which means that exact port. We're going to be using TCP TCP protocol, which is most commonly what you're going to end up using. And then we have a list of the CIDR blocks. This one is the suffix of /0. So the higher it is, the less IPs, the lower it is, the more IPs. So this means all 4 billion IPs that are out there are allowed to come in on the 22 SSH port. And we have another rule for incoming traffic. All HTTP traffic, which is the reserved port for that is 80, is also allowed, which is what you want since this is a web server. And we are allowing all traffic to get out. -1 protocol means both UDP and TCP. And also 0 means any port. And lastly, we give it a name. So there was one other file here, and that is the outputs. You can actually just throw these all into main. Like I said, Terraform's just going to run them all, but it is good to name them pretty similar to have them here. There is even more advanced stuff. There's modules that you can load in different Terraform folders, so you can have lots of different shared Terraform code. But this is basically going to give us the public IP for our instance. So I think we can try it out. So we made that Terraform folder. We put all those files in there. First part is to run Terraform init. And cool. It set up the AWS SDK. And we have a .terraform folder that is created. And I think it would have a Terraform state in there, but it's probably just going to say like, I'm the, UK. Terraform state. So here's the state. It's basically just saying I'm storing this in S3. So not super interesting, but that is how Terraform keeps track of what you have here. So we've run init, so we can now run plan, and we can see this is the dry run of what we'll get. Let me zoom this in a tiny bit. So we can see we are going to create 4 resources, and if it gives a lot of output, but we can see resource security group. Yep, we defined one of those, and there's the public key, and it has the value right in there. So a lot of these values, it says known after apply. And yeah, pretty much what it's saying, it's going to know that after it creates it. And I think we have our instance is what this is going to be. Yep. There's our instance. ARN is basically AWS like ID for a lot of stuff. And then we have I don't know why it does this, but it has the default VPC, says it's going to be created. It's not actually, but it helped us reference it in the file. So output looks good. For me on my job, you usually output that to a file, create a GitHub pull request, give them that file and say, here's what I would like to run. I did these changes. It's going to replace these files, and then you'll get some review on your pull request, and hopefully you're good, at which point you can push it out and hopefully have like a pipeline that will kind of automate the rest, but we're just going to do it locally here. So we like it, so we're going to go ahead and apply it. And you can run it with this flag, which means it won't ask us to say yes, but that's going to go ahead and create those resources. And let me make sure my AWS is open. Okay, so it gave us that same plan, but now it's actually going to run it. We have all this output about it creating these different things. And it is a pretty simple Terraform, so should take about 30 seconds. But if we refresh this over here, we can already see our instance showing up. We did give it the name of AL2, so that's it right there. This is probably really small. That looks a little bit better. So yeah, that is running. So let's check back at our Terraform. Apply complete. We're good. So it also gives us our output. So we can even go check this out. All right, where's Vincent? Is Vincent in here? What? No, I haven't shown him what my web server is, or my little web app, whatever. But we can go to this. So it's not encrypted, so it is going to be HTTP. If it gives us an error, it's probably because of that. So let's just type that in. Please work. So it tried to go to HTTPS, but it is HTTP. Let's try it one more time. Wait, why is it still there? Yeah, it doesn't seem like it's working for some reason, but I have one other demo, so we could just move on. It does say it's initializing, so maybe it's not ready yet. Or actually, I was thinking of the next demo I was doing after this. This actually just creates the machine. There's nothing on it. It's not serving anything at this point. So it's a little misleading that it gave me this IP because there's not actually anything going on there. So let's serve some HTTP traffic. We can SSH into it. We are going to use the EC2-user, which you can get that from Amazon. It's going to tell you that that's what the normal user is. And we're going to use this public IP, and SSH traffic we did allow, so we can SSH into it, but we do need to provide our key. So I'm going to give it the -i and then key, and we are going to say yes to that. And we are now into the machine, which is super cool. I need to know what to run. We are going to install Nginx on the machine. You do want to say sudo. So this is installing a web server on it. The command I ran was right here. Normally you install it from the package manager, but Linux has a preferred package manager. I don't know if it's a package manager exactly, but you're going to install it from that. For some reason, it has a Nginx 1 on it, but it's basically Nginx. And we now are serving HTTP or 8. We're now serving traffic on there. Actually, we need to start it. So we're going to use something called systemctl. That's pretty common for lots of services. So we're going to run sudo. And what sudo means is super user do. So that's going to give you a lot of permissions access. Usually you'll need to provide a password, but since we're logging in with our key, it already knows we're authenticated here. So we're going to run systemctl start. engine X. So we've started it. We can verify that with a status. So we have a running. So yeah, it started. So we can actually even go over there right now and check it out. Sure, let's do that. So yeah, we have that running. That's the basic Nginx HTML you'll get. We can go ahead and replace that. So I'm just running a editor on that HTML index HTML. You can see the full path of it there. It's probably a little small, but we can replace this and set up whatever we want on this web server. We'll do a little bit more in-depth stuff in a second. Okay, and don't know if we need to, but we're going to restart it. Probably do. So we have restarted that. We've replaced that file. So now we are serving that new HTML. I mean, it's not even really HTML, it's an H1 tag on that IP. So kind of cool. Let's go ahead and exit out of this and destroy it. So that's all good to run it locally, but ideally we want to automate that sort of thing. So in comes the GitHub Actions. So the setup for GitHub Actions, it's really simple. I use it for a lot of personal repos I have. You just create this .github folder. Create another folder within that called workflows. And then you can create a YAML file, name it anything. I named it actions here. But let's take a look at this. So we covered a little bit of what's in some of this. We name it here. We say what branches we want to push on. So any push on main is going to run this code here. It'll have a server that is going to run it. It's actually going to be Ubuntu. And then this is kind of a nice flag I like to run, or not flag, conditional for this whole job that's going to run. If it notices that it has brackets, no CI, it's going to not run a pipeline. So you can actually do a more sophisticated version of this where maybe you'll have like a README or just some folder that you know you don't need to redeploy your whole infrastructure for. You can set up, I believe it's like somewhere in here, but you can set up only these folders. If there's changes in these folders, then run the pipeline. Lots of information you can read about on the GitHub Actions docs, but yeah, we're going to check out the code. Apparently there's on version 3, I just realized that like yesterday, but cool. I'm going to set up the AWS CLI. We pass it. Again, these secrets are going to be coming in from something we configure within GitHub. I can show you what that kind of looks like. You can.
When I look at this script, it sounds like you're saying like they got pushed to one of these branches, and go ran, now we deploy, we got to do all some infrastructure.
Mhm.
And if you do that, it has zero proof on Devops, is that how you dumb it down to on GitHub?
Like how would I?
The way I'm looking at it now, to me, like, the point of a GitHub action is deployment release. You have to build files, put it in a drop folder. This is the point. That is
It's more open than that. It's really just kind of like a temporary server that can run anything. Most common thing is to do some linting, which will verify like the files are good, that it passes all the tests. And then typically companies will do what you're talking about where they deploy it.
Yeah.
You can do that in any way you want. Really, it's giving you a server that you can run commands on. So you can just run scripts. Company knows that before. Yeah, you just pull in scripts, you just download them and run them. But yeah, typically it's just
Powerful, because the most I ever did was quit with them just after DevOps. So like the builds area is very separate, at least there. That's why they see like everything at once.
yeah, you could do it all in one file. That you can, there's like jobs, and you can have the jobs give output and depend on other jobs, and those jobs can have steps. So there is kind of like some hierarchy to it, but yeah, essentially you can set up whatever kind of, it's pretty open. You can set up whatever you would want.
So let me give you an example from the pipeline.
Yeah.
Okay, so commit code.
Yeah.
And then this GitHub action, just think about it like you have stations so you can find whatever you want. So in our case, we have a station that's unit testing.
Yeah.
Okay, so in that YAML file, there's little lines where it basically just runs a Linux command.
Yeah.
So we have to use Golang, so go test, whatever the place is, it will run the test of the job. And like each microservice that we have, it can run, if any of it fails, the whole pipeline fails. If all of those pass, then the next stage in our pipeline is we're gonna build binary files.
Yeah.
Okay, right? And then, once we build the binary files, we use basically cloud formation. Yeah, that's here. It pulls those binary files and it uploads them to AWS and it provisions all the.
That's how software. Last thing build up initially to the poly code, unit test. Yeah, whatever you need to do that once the file is binary, just in the drop folder at that point, and that's DevOps release period. Once you place the drop folder, then it puts the dev prod. You might have scripts like this that. That's what I'm trying to create a parallel, so I can understand it. So, yeah. Yeah. Okay, sorry.
No.
Let's ask questions at the end, or?
Yeah, honestly, I haven't done too many talks, so I was just kind of blowing through it. So yeah, it's good to have the interruption. Yeah, you guys can hit me with any questions at any point. There's a lot of stuff I don't know. So honestly, it'd be good to just get info on some stuff sometimes too. So I was just trying to demo where you actually would set these secrets. It's over here, secrets.actions. Yes, sir. So I went to settings, secrets, actions, and then that's where I've set up my access key and that key ID. And then this is something for, I don't think we're going to use that, but that's the private key if I wanted to have these pipeline SSH in. So I was explaining that. Just continuing down, we are going to get Terraform from the Actions Marketplace. Again, anytime you see this uses keyword, that's going to be pulling something from the marketplace. And then we are not going to be using a GitHub action here. We're going to be, so each one of these is going to be a step. Usually it's going to have this little dash. You can see that's under the steps. And then here's this hierarchy for the jobs. And you can have these be dependent on other jobs, and you can have them, run after one another. So here we're going to actually run a very 2-line short script. You can make it multiple lines if you do this little pipe here. That's just a YAML thing. And to prevent us having to CD into it, we can set working-directory.terraform. That basically is going to, we've checked out the code, we're moving into it. This is almost exactly what we did locally, but we're just doing it on the server. So we have that Terraform folder, we're moving into it, running this init, running the apply. And at this point, we have that server set up. It's not serving, well, yeah, it's not serving anything at this point, but we're gonna do an SSH down here. To help that SSH, we're gonna find the IP. We're gonna use the AWS SDK. This one can get kind of like lengthy. It's not even printing the whole line, but this is basically the whole AWS. A lot of their commands are very verbose. And a lot of times you'll just end up having to Google to figure out like what the exact command looks like. But in essence, this is looking for a instance that has the name AL2, and it's going to be getting the IP. And I'm going to store that in host_IP. And this is one way each of the steps can interact with each other. So here, I ran that line, I got the IP, and I want to pass it over to my next step, which is SSH. But normally, I don't think if you set up that variable like that, that you would be able to use it in the next step. So we use this kind of syntax here, which is something from, yeah, I don't think that's Bash specifically. I'm pretty sure that's just a GitHub Actions thing. So yeah, might have to refer to the doc if you want to learn how to do that, but you can set the output. This is the key, and then the value is going to be what we got from this over here. So that's a little bit of our redirecting output happening here. I mean, it's not really redirecting, it's really just assigning it to that variable. So now we have host IP, and we can use it on the next step here, which is SSHing. So this is a uses, which means it's from the marketplace. And we provided the host, and this is almost exactly like what we were doing before. So SSH EC2 user at host IP, and then providing it the key. Remember, that's what we ran before. So it's using pretty much the same exact things here. It's asking for the key, it's asking for the host, which we've already set during that last step. And then it's setting the user to that. And then once we SSH in, we're going to run this script. One small security thing I should mention here. I don't really know what Apple Boy is here. It's I would definitely vet this. It is open source. But yeah, you would typically want to, it'd be better to run, I think there's an Ansible GitHub action you can use. So let's go ahead and do a push on this, and it should automate a build here. Okay, I've got like 1 minute or 2 minutes left. Okay. So we're going to go ahead and just do an empty push here, and it should build it. And we can head back over to the repo. There is the Actions tab. And it should show up here in a second. There it is. And we have our deploy job here. And this is queued up. And it's going to, once it has an available, we call them runners, it's basically just a little server that's just going to run that whole YAML that we got. And it is going to be using the Ubuntu image. So we can already see it's passed some of these steps here. We got our, let me scroll up. I can zoom it. We checked out the repo, we set up AWS, we set up Terraform, and now we are running Terraform just like we did locally. We get the plan. It's going to make all those things, and it's creating it. Once that's created, it's going to use the AWS SDK to get the IP, and then it's going to do an SSH. It does take a minute or two because the script that we're going to run on the SSH is a little bit more complicated than what we did before. So can take like a question or two if anyone has one. And it's going through the script now.
So I've never used Terraform first time. So all that is doing is creating the resources on AWS
Mhm.
During the beginning of the deployment, right?
Yep.
Okay. So that's like a primary function.
Yeah.
Okay.
Setting up your infrastructure as code and getting it deployed is kind of the main use case for Terraform. We're getting a lot more output than what I was doing locally. That's because there's a couple more things in here. It'll be a little surprise for my app that I made. Should be kind of cool. It uses 3JS, which is JavaScript model package. There's some cool stuff out there for that if you ever look up that. You can make games and stuff such in it. We can look at what some of it's doing. This is basically the code that it's running here. It's getting node, it's getting git, it's getting nginx, starting nginx, cloning my repo, going into it, installing the packages, creating a build, and then it's putting that in what nginx serves. So right now it's building the dependencies, which is third to last on our script. And yeah, like what was mentioned before, you can run tests. Once this is deployed, you can run integration tests and make sure everything's as you expect. You can set up different environments like your dev and prod. And yeah, just get it all automated. And you can automate most steps in that. Like 1 more minute. It's almost done. Want to show what it's going to serve in a second, if I could. It's literally, it's right on this step. It's close. We're right there. Yeah, well, I'll be done before that. And we're good. There we go. Check it out. Hey. And that's it. Okay, go ahead and stop the Zoom.